Good. All right, so let me guess. We're solving trig equation.
Yep.
Okay. If you like, I can search. I'm pretty sure I have the problems. Let me see if I can find them real quick.
What?
And they may not be exactly the same as yours. This one was from a couple of days ago. Oh. Are those yours?
No.
Okay. There was another one from that same, hold on. I think it was this one. Is that yours? That's not the same one, no.
No. Mine is like a multiple choice box section.
Okay. Or is it stuff you can verbalize? I'm hearing a
I should probably send you a picture.
Can you take a picture and send it to my email?
Yes.
Okay. Why don't you go ahead and do that? Not to my phone, but to my email. You have that?
Yeah.
David Cowan, 1949 at Gmail. Hold on a second. Do you have a bird?
Yeah.
Ah.
Sorry, she's laying eggs.
Well, that's okay. I was hearing weird noises, and I couldn't tell. I can never tell if it's coming from my house or from the speakers.
Oh, yeah, that's my
The
bird.
dog was upstairs, so I was wondering why is my dog making noises like a bird? Hold on one second while you're go ahead and send that.
All right.
Hello. Okay. Let's see. Okay. I was trying to figure out something else also. Now I understand. Let me know when you've sent it.
Sorry, the pictures keep coming up blurry.
Might have to have more light or use a steadier hand.
Yeah.
The steadiness of the hand makes a tremendous difference.
Okay.
And you may have your phone. Do you know how to look at the settings? I had somebody send me something the other day, and they had it on low resolution, and it came out completely blurry.
Okay.
And they had.
And I think it should be good.
Okay.
Hopefully. We'll see.
But that is a setting. I don't know why anybody would ever want low res, but in other words, I don't know why it doesn't always be on high res. I guess it creates a larger file.
Can I send it to you in 2 different parts? Or would that be, I don't know how to do.
Sure. You mean you have 2 different pages?
Yeah.
Yeah. Go ahead and send them. You can send it in 2 different emails, or you can probably put both of them, attach both. Send them both at one time.
Okay, let's see. Oh, these are all so...
There's one of them.
Yeah.
Do you have an option on your phone that says Gmail? Share with Gmail?
Not that I can see.
Okay, I have that option on my phone, and I use it, and I think it's a little better because it goes directly to my Gmail account. I think I can get it a little faster. All right. So, let's look at these. So we're supposed to match up 1 with A through F and so forth?
Yes.
Okay, that's a little brutal, but maybe not so much. I guess it isn't. Well, the only reason I said that was because that reminds me a little bit of having multiple choice verifying identity questions, and that really is not fair at all.
Oh, actually, that's our test next Tuesday.
You do not want a multiple choice verifying trig identities, unless perhaps it's something like this. The reason is that all the practice they give you are identities. You have no practice at all at not verifying. In other words, at finding stuff that is not an identity. And yet, when you have a multiple choice test, that's pretty much what you have to do. In other words, they give you the left side, and you can manipulate it, but you don't know what you're trying to turn it into. And so
yeah, we take test on Tuesday.
Well,
and we have another test like that on Thursday.
Well, she may make it like this. In other words, one could say this is technically a multiple choice, and this isn't going to be that hard. Let's simplify secant cosine. What's secant cosine equal to?
Secant times cosine? Oh, 1.
Okay, so that was easy enough. That was easy enough. How about tangent cosecant?
Cosecant is 1 over sine, and tangent is sine over cosine. So 1 over cosine, so secant.
Good.
X.
Good. In other words, these aren't bad if they're structured like this, and yet this is kind of multiple choice.
I can do this.
Yeah.
And so then that one would be equal to sine. Or no, I'm skipping ahead. So 4 or cotangent x squared.
Which identity do we want to use on this one?
The
Pythagorean identity.
Yeah.
That relates cotangent squared with cosecant squared. What is that identity?
Isn't it 1 plus cotangent squared equals cosecant squared?
Okay, so let's substitute. We got cotangent squared minus the quantity cotangent squared plus 1, right?
Yep.
That's equal to minus 1, so B. Okay, 1 minus cosine.
You get sine, right? That's equal to sine?
Sine squared.
Sine squared. And then cosecant would be 1 over sine.
Uh-huh.
And then you could cancel out, so you get sine of x.
Uh-huh. Good. You seem to know these pretty good.
Yeah. These are not so bad.
Yeah. No, the whole point of these is just to get you to memorize your trig identities.
Where's the ones? But these aren't so bad. Could we do some solving if we move down the page?
Uh-huh. How about just let's do this one. This is a little different one.
Okay. Oh, negative x. So for cosine it would be positive though. So for the top one you'd have to go negative sine x.
Okay.
For cosine x.
Okay.
And then that's negative tangent x.
Good. Where's the solving? Is that 15?
Numbers 16 and 15 are solving down there.
15, okay. Yeah, we can go back if we have extra time. That is a quadratic in disguise. And in fact, it's not even in disguise. A mathematician would say this is a quadratic in cosine x. Because you can have quadratics in all kinds of things. In other words, this is not totally different than this. And I can factor this. So treat these just like they're algebraic equations. In fact, that is the secret of solving trig equations, is just pretend they're algebra equations. And we're in the interval x greater than or equal to 0 to 2 pi. So we don't need all solutions. So like a quadratic, bring everything over on one side and leave 0 on the other. Now, factor that for me.
So you would have, we have to do the little, so 2 cosine minus 1?
Do it in steps. Don't try to do the whole thing at once.
Okay. And so then cosine x.
Okay. Sines are what?
Negative and positive.
Or, because the coefficients are different, it could be positive and negative, and it might matter. So I usually write it like that. It doesn't mean plus or minus. It just means that it could be minus or plus or minus. I should write a little or in front of there. Now, obviously, 1 and 1, if we just randomly plug it in, does that work?
Yeah.
No.
I think
Multiply the inside, multiply the insides, multiply the outsides, add them together. What does that produce?
Cosine, 2 cosine x squared. Oh.
No.
Wait,
Just,
plus or minus?
just the insides and just the outsides to check for the middle term. In other words,
2 cosine x?
Yeah. That adds together to be positive cosine x. So it's not the middle term, but it's the right number. It's a 1, which means is all we have to do is move that one to there and that one to there, and we're going to have the right answer. And that's always the way it works. If your first trial and error produces the right number, wrong sign, then just move your number down. Okay, notice this produces a plus cosine x in the middle term, minus 2 in the outside terms, giving you minus cosine x in the middle. Okay. Now what?
Okay, and then you set those terms equal to 0.
Okay, so we'll start with the easy one. Cosine x equals 1. Where does that occur in the unit circle?
That occurs at cosine 0. I can't find my table.
Are you going to be able to use your table on this test?
Well, we have to make a table, but
Oh,
I
okay.
have one already made
Okay, I gotcha. Okay.
somewhere.
Because this really, you really should, instead of a table, is all you have to do is memorize what the curve looks like. There's the cosine curve. You know it always bounces between 1 and minus 1. The period is exactly 2 pi, and that if you quarter it, those are all the key points. In other words, this is where the maximum occurs. This is where the first 0 occurs. This is where the minimum occurs. That's where the next 0 occurs. This is where you get back to the maximum. You should have this memorized. This and the sine curve. The reason is it allows you to answer questions like this real easily. And you don't need to look at a table or any of that. This is something I feel like you should have memorized, these two curves. And everything about them. In other words, the quarter points, the 1 and the minus 1, all of that. Okay? So we can see from this curve that it's only equal to 1 right there. Well, it's also equal to 1 at 2 pi, but 2 pi is actually outside of our domain. Notice the domain is less than 2 pi, not including 2 pi. So x equals 0 is the only solution for that. And then how about the second one? We have cosine x equal negative 1/2. Now this almost always involves two solutions because it's not a quadrangle. It's not going to be 90, 180, or 270. which means there's going to be two different quadrants where the cosine of that angle is going to be equal to minus 1/2. Which quadrants is it negative?
It is negative in the second quadrant.
And?
The third quadrant.
Okay. What is the first quadrant answer? That's the way I like to do trig, is put everything as a first quadrant angle and then figure out what the second and third would be.
The first quadrant for 1/2?
Uh-huh.
Yeah, the first quadrant would be, I have to think about this, it would be 60 degrees.
Okay. That's a good one to memorize. Sine of 30 equals 1/2 and cosine of 60 equals 1/2, since they're cofunctions of one another. So that's not an answer, but it helps us come up with the second and third quadrant angles. What's the second one?
It would have to be 180 to 120.
Uh-huh. And the third?
Would have to be, wait, I have to think about this. 300 degrees?
Mm-hmm. Okay. And the only other question I have is, since they restricted the domain to 2 pi, do they want your answers in radians?
For this part, I guess so.
Okay. This is pi over 3.
Yeah.
Well, I know this is 2 pi over 3. And I know this is 5 pi over 3. And I guess I've just memorized that from doing them. I didn't do a conversion in my head. I'm used enough to working in radians that that's the way it is. So here's your two answers for the second part. 2 pi over 3, 5 pi over 3, and that doesn't seem
and
right.
Pi, because
yeah, and
I don't know why that
0. Yeah, 300 degrees, is that 5 pi over 3? Yeah, yeah, because it's 1 pi over 3 short of 6 pi over 3, and that's 60 degrees. So, okay, so here's our 3 answers right there. And a lot of these problems are going to be like that. I'm guessing 16 is going to be very similar. No. Okay. A little different. Oh, okay. That was multiple choice. Yeah. Ooh, did I do that wrong? I must have done it wrong. Oh, no. This is it, huh? I did do it wrong. Did we just do 15? We did.
I think so.
What are these answers? 0, 5 pi over 6, and 7 pi over 6?
I don't know. Well, I was thinking, okay, could it be G? Because my teacher said something about having to use your unit circle identities.
Hold on a moment. Yeah, that's the hard way to do it. Did I make a mistake in my math here?
I don't think so. I think it's just with the pi.
Oh, just in stating the degrees in terms of pi? Well, I don't see the correct answer. What is the correct answer up there?
Well, cosine is, I don't know. Cosine is x, right? So you have to go to where x is equal to 0. Right.
Let's see. Cosine is 1 at 0. So clearly we need a 0 in our answer. So the answer would appear to have to be A or B. But A is second quadrant, and that is third quadrant. Is that what we wanted? Cosine is negative. Yeah, okay, now I get it. I did make a mistake. It's not 300 degrees. 300 is in fourth quadrant.
Okay.
What is the third quadrant angle?
Third quadrant angle?
460.
Wait, why is it not 300?
Because it's 180 plus theta. So add 60 to 180, you get 240.
240.
Uh-huh.
I was going fourth quadrant.
Right, you were. And
problem.
cosine is positive in the fourth quadrant. But that is 1 pi over 3 greater than pi is kind of the way I think about it. In other words, I know pi over 3 is 60, and this looks to me like pi plus pi over 3, right? Because that's 180 plus 60, well, that's 4/3 pi. Yeah, I didn't catch that error. Well, that's good. That makes me feel better. So answer B is correct. And let's look at C. Let's cover up the multiple choice. We don't need the multiple choice here. There's nothing wrong with a multiple choice on trig. It's the only type problems that it really makes difficult are the verifying trig identities. Those are particularly more difficult than a non-multiple choice would be. Okay? What's the first step here?
To subtract 2.
Okay, so we have this. And then how you do it from here kind of depends on how you like to do it. I tend to convert everything to one of the 3 primary trig functions. I suppose that's a habit just from the Texas Instrument 84 only had the 3 trig functions, and you had to solve all of these by converting it to sine. And I still think that's the easiest way to do it. In other words, if cosecant x is equal to -2, then what is sine x equal to?
Minus 2 over 1?
Minus 1 over 2. It's the reciprocal.
Oh, yeah, because you put secant on them.
Right. Okay, and we're used to that. I know what that is. So what is x going to be? In other words, we can now solve this. We can convert it to one of the top 3 instead of dealing in cosecant. Perhaps you don't need to do that. I don't know. For me, it's more comfortable doing that. So what's the first quadrant angle that sine x equals 1/2?
First quadrant angle would be, wait, for negative or for 1?
Well,
so, okay,
it
never mind.
depends on how you do it. If you got them all memorized, go ahead. Far be it for me to back you up. But the way I do all of these is I figure out what the first quadrant angle is. And then I know that we have to be in the third or fourth quadrant. And so I figure out the third or fourth quadrant angles that correspond to that first quadrant angle.
Okay.
Let's go through. Let's go through it.
30 degrees.
Okay, so it's 30 degrees, pi over 6. But which quadrant are we in for it to be negative?
For it to be negative, it would have to be, wait, so now we're doing the negative quadrants or all the quadrants?
No, we're doing this right here.
Yeah, okay, never mind. Sorry, I thought we were just listing, okay, never mind.
No,
So,
I put in this step myself. That's not really a necessary step. If you've got your unit circle memorized, you don't need this step. But I don't have it memorized. I don't really feel like that's the way to learn trig. I feel like it's better to learn trig by basing everything on a first quadrant angle and going from there. So if sine of x was equal to positive 1/2, we'd be looking at this angle here. The fact that it's equal to negative 1/2 places it in which quadrants?
The third quadrant?
That's one of them.
And the fourth.
Okay. So now, what is the third quadrant angle that goes with 30 degrees?
So it goes with 30 degrees, so it would be 180 plus 30.
Right.
So 210.
Right. Or you could say pi plus pi over 6, which is 7 pi over 6. Since, again, we probably want our answers in radians. And then in the fourth quadrant, what is it?
So 330.
Okay, which is a pi over 6 short of 2 pi. That makes it 11 pi over 6. That is a pi over, you see what I mean when I say it's a pi over 6 short of 2 pi?
Yeah.
That's that 30,
around the
that's
circle.
the 30 degrees. Yeah. In other words, rather than going through the more complicated conversion of pi over 180 and having to do that math, I'm trying to think directly in terms of radians. So your answer is 7 pi over 6 and 11 pi over 6.
Okay.
B again. Okay. We got time for one more problem. Pick one if you like.
Just number 6, how about?
What's that?
Go back to number 6, just
Okay.
get it over.
Yeah, no, that's fine. You may have to read it to me.
Oh, okay. Sine, and then bracket, pi over 2, parentheses. Yeah.
Bottom is cosine, bracket, pi over 2, minus x.
Yeah. Uh-huh.
Okay. The cosine is a cofunction of sine. The cosecant is a cofunction of secant, and the cotangent is a cofunction of tangent. Those are not the reciprocal relationships. Those are the cofunction relationships. Every cofunction relationship shares this property, that the sine of x equals the cosine, its cofunction, of pi over 2 minus x, and vice versa, meaning the cosine of x equals the sine of pi over 2 minus x also. This is same for secant, cosecant, same for tangent, cotangent. So I can replace the top with what?
With cosine x,
And the bottom with what?
sine x. And
Make
so
it
cotangent.
cotangent x.
Cool.
Let me just have a peek at some of these others and see if I can spot a particularly difficult one. That's, let's see, sine times secant. Well, secant's going to be 1 over cosine, so that'll be sine over cosine. That'll be tangent. That's going to be cosine squared times tangent squared. Tangent sine over cosine, so that's going to be sine squared, C. Number 9. That's the difference of squares, is one way to look at it. Even though it's the difference of cubes, it still qualifies for the difference of squares because I can do this. Right?
Yeah.
In other words, it doesn't have to actually be squares. It could be anything that you can take the square root of. Now, what is secant squared minus tangent squared equal to? Always think of your trig identities. There's only 3 of them. Whenever you look at a square, that's the first
So it
thing
would
to
be
think of.
1 and...
That's it, 1. Meaning our answer is F, secant squared plus tangent squared.
Easy enough.
Okay? And unfortunately, I have a 5 o'clock I got to go to. So,
All right.
but
Well, thank you.
I think you're in good shape on these. Okay, Sarah. Talk to you next week. At the normal time, I presume?
Yeah.
Okay. Bye-bye.
All right, thank you.